Hello guys, so today I'll be solving this problem. So this is today's LeetCode's daily challenge. So the question name is maximum number of K-divisible components. Okay, so the question states that like we have been given a graph. So let's take this graph. Okay, so yeah, so 1 is connected to 2 is connected, then again 1 has a child 3. Okay, then 2 is connected to 4, and it's also connected to 0. Okay, so we have been given this graph, but they are saying that as this is an undirected tree. So yeah, now the thing is, so to represent the tree or the graph, so they have given us edges. So edges will basically say which nodes are connected to which. Then then we have been given a values array that basically stores the value for my node I. Okay, and yeah, so the main problem statement starts from here. So what we need to do is we need to split this graph into multiple connected components such that for every connected component, okay, the sum of nodes, okay, in that connected component, or you can think of that as a subtree, okay, such that the sum of the nodes in that subtree should be divisible by k. So they have given a k parameter here. Okay, now the question says that we need to maximize the number of components or the maximum splits we can do on the graph. Okay, so this question is labeled as hard, but I don't think this is that much of a like harder problem. So in code force system, I will rate it as like between 1200 to maybe 1400, in that range, because here if you run some example, you can easily find the intuition to solve this problem. Okay, cool. Now how to proceed, so how to solve this problem. Okay, so let's make a claim. Okay, so our claim is, okay, as soon as, or let's say anytime, okay, anytime I'm getting let's say a subtree, okay, whose sum of nodes in that subtree, okay, is divisible by k, okay, I'll simply remove the edge between the root of the subtree and the parent of that node. Okay, I will remove the edge between root of subtree and the between root of the subtree and the parent of the node. Okay, so what do I mean is, let's say I have a subtree, let's say I have 1, 2, maybe 3 and 4 here. Okay, so I'm saying that if I have a subtree, let's say this guy, okay, if the sum of nodes in this subtree is divisible by k, then I will simply remove this edge. Okay, so this will look like 1 here, 2, 3 and 4. Okay, now how to prove this claim. Okay, so let's take this example. Okay, let's take the example of let's say I have 3, okay, let's say I have 6 and I have 9. Okay, and let's say k equal to 3 here. Okay, so let's say if I start from the leaf nodes, okay, and I keep on pushing the sum or the values of this leaf node to my parent. Okay, so this is how we build the sum of these subtree, right? So yeah, so let's say for this graph where k equal to 3 and I have these three values. Okay, if I don't cut off the tree, okay, let's say I start with 6. Okay, here I can see that for 6, okay, uh, so 6 itself is a subtree, right, where it has like no children. Okay, so for 6, okay, 6, the sum of the subtree is already 6, which is like divisible by k. So if I waited, or if I wait here, okay, and I push the sum to 3, okay, similarly for 9, if I wait and I simply push the sum to 3, okay, then what I will be doing is for 3, let's say now I will check whether the whole sum is divisible by 3 or not. So in that case, this will be what, 9 plus 6, and which is like 15, 15 plus 3, which is 18, okay, and 18 mod k is 0. So yeah, in this way I'll be getting only one component, right, which is like this subtree itself, like 3, 6, 9. Okay, but as per my claim, if I do it, okay, so as soon as I get a subtree whose sum is, or the sum of nodes in that subtree is divisible by k, if I simply remove it, then let's see what I will get me in my answer. Okay, so again 3, 6, 6 and 9. Okay, so if I start from 6, okay, so 6, the sum of the subtree where the root node is 6, so that is 6, which is divisible by k. I cut off this node, okay, and let's say I have an answer variable, I will increment by 1. Okay, now I will be left with 6 here, 3 and 9. Okay, now for the next leaf node, which is 9, I'll check if where 9 is the root node, what's the sum of all the nodes where 9 is the root node for that subtree. So there the sum is 9. Okay, basically I'm looking at this. Okay, and here I was looking at this. Okay, so if I look at this subtree, the sum is divisible by k. Okay, because 9 is a multiple of 3, so it is divisible by k. Now let's say I cut here. Okay, so I will increment my answer by 1. Okay, so finally it will look like 6 here, 9 here and 3. Now when I am at 3, okay, here the now 3 is like cut off with its children, right? Now the sum of nodes, okay, where 3 is the root node, okay, is so the overall sum is 3 itself, which is again a multiple of my k, because my k is 3. Okay, so this also satisfies, so I will increment my answer by 1. Okay, so finally I am getting like 3 components who like that are satisfying my divisibility by k condition. Okay, but if I go in this approach, okay, if I go in this approach where even after getting a subtree whose sum is satisfying the divisibility condition, okay, I'm waiting and pushing the value to my parent, okay, then I'm getting lesser number of components, right? Here I'm getting one component, whereas here I'm getting 3 components. Okay, so this strategy works. Okay, so we can greedily think of this like, as soon as I'm getting a subtree whose sum of nodes is divisible by k, I'll simply cut off the node and the parentage between that. Okay, so yeah, that's the strategy. Now let's think of how will we perform the cutting. Okay, so what we are doing, so when I have a tree, okay, and when I'm trying to find out the sum of nodes of a subtree, so the basic strategy is to apply DFS, okay, get to the leaf nodes, okay, and once you are at leaf nodes, you simply return the value of the leaf node, okay, or add the value of the leaf node to the parent. Okay, so in this way we will be like doing the subtree summation calculation, right? Okay, so for this child this will put its value to the parent sum. This guy will also put its value to its parent sum. Now this two will put their sum value to their parent, and now finally for this node, this will put its value to its parent. So this is how we perform the recursive calls, and we calculate the subtree summation values, right? Now here, let's say if I cut off maybe this edge, okay? If I cutting off this edge, so whatever contribution I was getting here, okay, now for this node, that contribution value will be 0 now, right? Because if I'm cutting off this edge, so there is no connection between this subtree, right, with this node. That means if I simply push a value of 0 to my parent, then I can simply replicate, or I can simply say that I'm cutting off that edge. Okay, so here I can say if let's erase this. If I'm cutting off the edge, I will return 0 to the parent. Okay, now what's the other case? So I'm cutting off the edge only when the sum of the nodes in that subtree is divisible by k, right? Now it may happen it is not divisible by k. So in that case, I will push the node value or whatever subtree sum I have gotten to the parent sum. Okay, I'll push, or I will return the subtree node values, or the summation of nodes in that subtree, to my parent. Okay, now from that parent I will again check, because now my parent will be rooted for that for its own subtree. Now I'll check whether the sum is divisible by k. If it is, then maybe I will increment my answer. So yeah, so that's the idea behind the question, and this is the strategy for cutting. Okay, so if I use my claim and this cutting strategy, then I can easily solve the problem. Okay, so let's do it in this example. So I already have drawn this. Okay, so this is the node connection representation. So this is my graph. Now let's instead of node IDs, let's put the values here. Okay, so for this test case, okay, I have the values. So for 1 I have 8. Okay, then for 2 I have 1. Okay, for 3 I have 4. Okay, and for 4 I have 4, and for 0 I have 1. Okay, so this is the value of node, okay, in the tree or the graph. Okay, now in my so in this test case, k is 6. Okay, cool. Now let's start from the bottom. Okay, so I'm seeing, so I have 4. Okay, so for 4, for its own subtree, is it divisible by k? Nope, 4 is not divisible by 6, so it's not. So I'll push the value to my parent. Okay, so now my parent will become so I will do a +4 here. So now my parent will become 5. Okay, 1 + 4, 5. Okay, now I will go to this leaf node. I have 1. Is 1 divisible by k or 6? No. Okay, so I'll push the value to my parent. Okay, so I'll do a +1. Okay, so finally this will be 6. Okay, now when I'm at this node, okay, I'll check the subtree sum value. Okay, now the subtree sum value is 6 here. Okay, now is 6 divisible by 6? Yup, it is. So what I will do is I will cut off this edge, which basically means I will give a 0 contribution to my to this node's parent. Okay, so I will push 0 to the parent. Cool. Now for this leaf node, Okay, again, so it's 4. So is 4 divisible by 6? Nope. So I'll push 4 directly here. Okay, now when I'm at this node, okay, I'll sum up all my child contributions, okay, and finally I will get the subtree summation as 8 plus my left child contribution, which is 0, plus my right child contribution, which is 4. So it's 12. Now is 12 divisible by 6? Yes. Okay, so this guy and this guy, okay, are creating one component that is satisfying my k divisibility. Okay, so 8 and 4 is one component, and this subtree is satisfying is another subtree which is satisfying my divisibility condition. So 1, 4 and 1. So I have two components, so the answer is 2. Okay, so I can see the answer is 2. So yeah, that's the main idea behind the question. So just perform a DFS. Okay, start from the bottom, and from the bottom create your subtree summation. Okay, so as soon as you got a subtree which is like whose sum is like divisible by k, cut off the edge for that node to its parent. Okay, or basically provide a 0 contribution to the parent. So yeah, let's code it up in C++. Okay, so what I need, so here I have been given edges. So in order to perform DFS, I need an adjacency list. So I'll create a vector of vector, I'll call it G, and this will be of size n. Now I'll iterate over edges. So for E in edges, okay, so I'll push my nodes. Let's say A equal to E of 0 and B equal to E of 1. Okay, I'll say G of A, push back B, and because this is a undirected tree, so I'll be pushing both of them. So in B I'll be pushing of A. Cool. So after this, our adjacency list is done. Now in order to perform DFS, so we need a visited array. So let's quickly create that. So I'll say vector of bull and visited, I will say n, and by default they will be initialized to false. Then I will need another data structure, okay, or a map, so that I can store the subtree summation. Okay, so whenever I'm performing the DFS call now, so for every node I need to get their summation, right, or the subtree sum. So in order to capture the sum, I will create another vector of maybe so here the node values vary between 0 to 10 to the power 9. So it may happen my integer data type might overflow, so I'll use long. So let's create ll for long. So I'm creating ll as a alias here. So I'll say ll, and let's call it sum. Okay, and this will be of size n. So for every node, okay, if I'm treating that node as a root, so whatever subtree it holds, I will capture the sum here in this array. Cool. Now let's write our DFS. So I'll be using a lambda here. So I'll say so self, and it takes a node and it returns me the subtree summation, and it will be returning me long. Okay. Then I'll be calling my DFS over 0, and finally I'll be returning an answer. So I'll create my answer variable here. So answer this. So the answer will capture the splits that I'm making. So okay, cool. Now let's write our DFS. So inside my DFS, if I have already visited this node, okay, I can simply return 0 here. Okay, otherwise I will mark this the node as visited. So I'll say true. Okay, then I will update its subtree value, or I will initialize subtree value with the value of this node. So I'll say sum of node is values of node. Cool. Now I will iterate over all the children of this node. So I'll say for auto neighbor node in graph of this node. So now here what I will be doing is I will be adding up the contribution of my children. Okay, so I'll say sum of node, will be, I will call the DFS over its children now. So DFS self of self with n of node. Okay. Now, after I have added up the summation, now I will check whether the sum of this subtree, okay, is divisible by k or not. Okay. If it is, I will increment my answer. Okay. And now I have, so it means I need to cut off the edge of node with whatever parent it has, right? So I will basically push a contribution value of 0. Okay. Otherwise, if its subtree is summation is not divisible by k, I'll simply return the sum of node. Okay. So this is what we have observed in this test case, right? So yeah, this is the code, and I hope this should work. So let's run this. Cool, everything failed. Let's see. One thing, so these are int, so I need to convert them into this. Now I have my node here. Okay, then yeah, here in summation also I will be converting them to this, but yeah, this shouldn't be the issue. So the issue should be this. So if everything is 0, that basically means it never got, okay, it never got this. Then I'm calling self of node, then I'm calling vals. Let's check one more. Oh yeah, so as for this condition, so for every node I'm saying if I have not visited, simply return 0, so that's why. So yeah, if I have visited this node, then only return 0. Cool. Now let's submit this. Cool. Everything passed and we have successfully submitted it. So now let's look at the time complexity of it. Okay, so we are basically performing a DFS call, right? And in that we are basically touching over all the nodes, right? And from that we are not doing any other operation. After that, all of them are like constant time operation. So the overall time complexity will be a big O of n, where n is the number of nodes I have. Okay, then let's look at the space complexity. So for space complexity, I am creating a vector, okay, of for this graph creation, where I am basically storing all the nodes. Okay, then I have a visited, and yeah, so there is no extra. So the only extra space I am creating is of size of number of nodes. Okay, so here I'm just pushing it twice, like A is storing B, B is storing A, so that can create a 2n space complexity at max, which is like equivalent to big O of n. Yeah, so yeah, this is my time complexity. So yeah, this is my time complexity, and I think it's pretty efficient solution. Cool. Now let's do the same thing in Golang. Okay, so I'll be creating my graph first. So I'll say graph is make of matrix, and this would be size of n. Now I will push my nodes to my graph. So I'll say for e in range of edges, I'll say let's say a equal to e of 1, e of 0, b equal to e of 1. Now I'll say g of a equal to append of g of a and push b there, then g of b equal to append push g of a there. Then I'll be creating my visited array. So I'll be saying visited of let's create a make then array which contains bool, and this should be of size of n. Then similarly I'll be creating my sum array. Now I'll say make, and this will be of size int 64 because it can overshoot. so this should be also of size n. Then I will create my answer variable. I will initialize to 0. Then I will say ans. Then I'll be writing an anonymous function for my DFS. So first I will write the signature for my DFS. I'll say DFS is DFS, and it takes a function of node and int. Okay, cool. Now I will declare my DFS as a function that takes node int. Okay, and yeah, it will return int 64, like the same thing that we observed in C++, right? So we are returning long. So here I'll be returning int 64, and now I'll be writing the definition of it. Cool. So I'll say that if visited, if I have already visited this node, okay, here I will not make that mistake, so I will simply return 0. Okay, otherwise I will mark this node as visited. Then I will update the sum of this node, or I will initialize the sum of this node to the values of this node. Okay, now I will go down. I will perform DFS over its children. Okay, so I will say for the neighbor node that I have for this node in my g of node. Okay, I will update the sum of this node by calling the DFS again for its child. Okay, now after this, if I am getting this sum divisible by k, okay, then I will increment my answer, so answer plus plus, and I will be returning 0 to my current node's parent. Okay, otherwise I will be returning the whole subtree sum. Okay, then finally I'll call my DFS over 0, and I'll be returning ans. Have I written ans? Yeah, I have already written this. Cool. Hopefully this should work. Let's run this, and let's use the compiler. Cool. Yeah, so declared it as int64, so this should be of size int64. Now based on this, I think here also I need to perform int64 because k is of size int, which is like int32, sum is int64, so yeah, I think this should work. Yeah, cool. So the same code that we have written in C++, we have successfully written in Golang. Cool. Now let's finally do it for Rust. Cool. Now this will be a bit of a challenge because creating anonymous function in or like lambda function in Rust will take some time. So I'll stick to normal DFS implementation. Okay. So first thing first, so I'll be creating my graph. So I will say let mut g equal to this, and I need a vec of usize, and I'll be calling new, and yeah, because now I'll be using usize because the nodes will be acting as indices, so yeah, they should be of size they should be of type usize, and yeah, I need n of them. Okay, and n is i32, so I need to so I'll be using n multiple times, so yeah, I'll say n. I will declare another n, and I will say n as usize here. Okay, and I can use this n here. Okay, cool. So g. Now I'll update my adjacency list, so I'll say for edge in edges. Okay, let's create a equal to e of 0 and of size usize of data type usize, and let b equal to e of 1 as of data type usize. Cool. Now then I will push inside a, I will push b, then inside the adjacency list of b, I will push a. Cool. So adjacency list is done. Then I will create my visited array. So let mut of visited equal to vec of I'll return everything false, then this should be of size n. Then similarly what we did for C++, I will create another sum to capture the sum of the subtree. So I will initialize to 0, and this should be of size n also. Cool. Now after that I'll be creating my answer of 0, and then finally I'll be returning my answer. And here I will be implementing my DFS as a method. Let's call it pub fn DFS. Now it takes a lot of arguments. Cool. So I'll return my DFS here, so it will return I64. So here I'll be calling my solution DFS. Okay, so what all things we will require? So we will require the node, right? So now node will be of u size, because I'll be using this node as indices. Okay, then I'll be putting my visited. Okay, so visited will be of vector of I32. Okay, then I'll be updating my, so I'll be updating my visited array, so I'll be taking a mutable reference of it. Okay, cool. Then the next argument will be my graph itself. Okay, so I can take a reference of my graph. Okay, my graph is of data type vector of u size. Then finally I'll be no, not finally, I'll be using my sum also. So yeah, I32, I64. Yep. Then I'll be giving my values also, so this will be again a reference. Okay, I don't need to borrow it. Then I also need k, right? So maybe I will pass it like this. Okay, then I will be updating my answer, so I need to take the mutable reference of my answer, which is of I32. Cool. Now here I'll be writing the same stuff what I wrote for C++ and Golang. So I'll saying visited of node. So if I have visited this node, then I will simply return 0. Otherwise I will mark this node as visited now, and I will update the sum of this node as values of node. Okay, then I'll be iterating over all its children. So a node in graph of this node, so I'll say sum of node plus equal to my here also solution DFS. So here I'll be passing my n node, my visited g, then my sum, then my values, then k, then my answer. Cool. Whew. Then I'll be saying my sum of node. I'll be checking if my sum of my current subtree is divisible by k. If it is, then I will be updating my ans. So ans is a reference, so I need to dereference it, and I will increment ans. Then I will return 0 to my parent, which basically means I'm cutting off h from my parent. So if you guys have seen Bagban movie, so it feels like that. Yeah, it's an Indian movie, you guys should watch it. So yeah, otherwise I will return sum of node. Cool. So sum of node here, so it should work. Then I'll be calling my DFS here. So here I'll be starting with 0. Okay, then I will be giving my mutable reference to my visited. Okay, so mutable reference to my visited. Then I'll be giving a reference to my graph. I only need to read it. Then I'll be giving the mutable reference to my sum. Then I'll be giving the read reference to my values. Then I'll be passing k as it is. Then I'll be pushing answer. Cool. And with that, I think this should work. Fingers crossed. Let's see. If I run this, it didn't work. Yeah, because visited is of bull. Yep. I created bull. Yes. Now let's run this again. Yeah, cool. Similar issues. So I will be changing it to I64, which basically means here also I need to change it to I64, because yeah, this is of I64, K was of size I32, so I will be converting to I64. Let's run this. Taking time. Cool, it worked. Then let's submit it. Cool. So all three languages, and this is the logic. So I started with the claim. Okay, now I also showed you like how I'm like proofing my claim with the test case of this. Then there was this cutting logic, okay, where we are pushing 0 to the parent when I'm getting a subtree whose sum of the nodes is divisible by k. Otherwise, I'm pushing pushing to the parent the entire sum of that subtree, okay, and then I'm checking for the parent. So yeah, that's the logic behind this problem, and yeah, so I hope you learned something new. So if you find this video helpful, please do subscribe and like this do subscribe this channel and like this video, and yeah, just stay tuned to watch more videos. Bye bye.